Morning everyone, welcome back to the channel. In the previous video, we have seen node port service, but in today's video, we are going to understand one of the most important and production level Kubernetes service type, which is called load balancer. However, when we create a load balancer service in Kubernetes, what really happens? We just apply YAML file, suddenly one public IP or public DNS name comes and application becomes accessible from the internet or outside the cluster. But what is happening behind the scene? That is where most technical hurdles start. So in this video, we will clearly see the complete flow from the internet to the pod, which is container, where the application is running. Along with, we will see live demo and one real-time use cases where this load balancer will be very much helpful. Okay. Eventually, after this video, load balancer service will be clear for you. Okay. So let us understand the one problem statement first. Imagine you deployed your application inside a Kubernetes. Your pods are running perfectly. Internally, everything is working fine. But now, as per the business requirement, the business people say we want customers to access our application from the internet. You tried cluster IP not accessible from the outside. You tried with the node port service. It works. However, since node port is for non-production environment access and ports are fixed range, and when comes to the security, which is weak, this is not suitable for production grade. So the real question becomes here is how the big companies exposes Kubernetes applications securely, reliable, and scalable to the outside the world. This is where load balancer service comes into the picture. So that means where the cloud and Kubernetes integrated together. So now let's see what is the load balancer service in Kubernetes. So the load balancer service is a Kubernetes service type which automatically provisioning a cloud load balancer when we do apply for the service YAML and connects it to our Kubernetes service. Pretty much when you create a load balancer service in a cloud, Kubernetes like EKS cluster, AKS cluster, or GKE cluster, the cloud creates a real load balancer and then public IP or public DNS is assigned. Then the traffic is distributed and finally it forwards the request to the Kubernetes service and finally it will reach to the pods. That is where production grade access happens. Okay, then we'll see how the architecture looks like and how the flow will be happening end to end. So first, if you go to any application, users sends the request from the browser, which is he can take that public DNS or FQDN name, he can put into the browser and he can press enter. The request reaches the public IP of the cloud load balancer, which is DNS name. Then load balancer forwards that traffic to the worker nodes. And then Kubernetes service receive the traffic and the service forwards to the correct parts. Then the container process the request. And then finally, the response goes back the same way. Okay. So despite of multiple nodes and parts, user always hit the only one public endpoint, which is public DNS. So this is where we will see high availability and the auto scaling also will happen because in this scenario we are going to use EKS cluster and the traffic distribution happen between the healthy parts. Okay, so for basically here we will see how the load balancer service type works in Kubernetes, and in going forward, once the all objects are completed, we will do the couple of projects. That time again we can reuse all these objects. So the load balancer is very important service in Kubernetes. We can do more security. We can use this load balancer we can make our architecture or application should be high availability, and even we can do auto scaling as well. So the traffic distribution happening into the healthy parts. So that we will see into the coming projects as well. Just we will see the live demo here. See, for live demo, I was using EKS cluster. So in the next video, I will show you how to create the EKS cluster with the simple code. I can do one video for this. So first, I will deploy one simple Nginx pod actually here. See here, kubectl get nodes. I was using EKS cluster. So I used to deploy this EKS cluster by using Terraform code. So before going to deploy, let's understand the code base first. cdlb, here we are using deploy.yaml, where we are using Nginx application, and we can use service.yaml, which is load balancer service. Cat deployment.yaml, here you can see I was using labels name is lb.demo, load balancer.demo, and then I can use the 3 replicas. Okay, so the container part I was using Nginx latest image. The container name is Nginx. Okay, and the main thing is the container port 80. And then we can see that a load balancer service here we are using the type load balancer, and rest all is same as for node port. Okay, and make sure the selector and label should be match. lb-demo, here lb-demo, and the service port we are using 8080, and the target port we are using, which is called container port 80. Okay, so this is about code. Now let's create the Nginx application. kubectl apply-f deployment.yaml, kubectl get parts, and now it's running. Then kubectl get parts -o wide. See here, these are the node IPs. Okay, then kubectl get parts -show -label. So this is the label we applied, lb-demo. Okay, now let's create the load balancer service. kubectl apply-f load balancer svc.yml. See, before creating this load balancer service, first let's go to that AWS portal and we will see any load balancer is created or not. Because when we create a load balancer service, this is where the cloud is creating a real load balancer in the background. So that's what, before apply this command, let's go to the AWS dashboard and we will see. So let's come down, click on load balancer on left side. So now see here, there are no load balancers as of now. So when we apply this, let's go and watch. See here, it's creating now. So that means by default, when we create a load balancer service type in Kubernetes, the classic load balancer type is created. If you want, we can change this type also, like network load balancer and application load balancer and classic. Okay, these types we can mention in that manifest file, that we will see it in the later. Okay, so time being, what you need to remember is when we create a load balancer service in Kubernetes, the real load balancer is created by the cloud, which is default type is classic load balancer. Now kubectl get svc. See here, the DNS name, which is public DNS name, is given here. kubectl describe svc, and this is the svc name. If we enter, it will give all the details, but time being, you can use the DNS name curl the DNS name, and we can give the 8080. So now see here, we can able to access inside the cluster, and the main requirement is when we can use the load balancer, we can able to access it from outside the cluster with the securely :8080. You will see in Nginx welcome page here. Even the load balancer will distribute the traffic to different parts in the backend. So for that, what we can do, let me go to the container and edit something. kubectl get parts. Then let's go to the inside of the first part. Okay. Now let me edit echo. This is part 1 and append /usr share nginx html in index.html. If we can enter, then again came out, we can do for other parts as well. Now copy this and paste it. You can make it as a part 2. Again same thing for part 3 as well. Then exit, and what you can do, so now if I can refresh, I will get part 1. After 1 minute you can try to refresh, load balancer will be redirect the traffic to another part. Okay, self of this command also we can come to know where the load balancer will redirect the traffic to respectively. See here, we can able to see internally, it will switch to the part 2, part 2, part 3, part 1 like that. But in the web page, let me refresh again. Earlier it was part 1 is there, now it is redirect to part 3. So this is how, if we can refresh this one after every 1 minute, so it will be redirect the traffic to multiple parts. Okay, if you want, even you can verify in the curl fkdn name :8080. Here also you can see the traffic. See, earlier it was part 2, now it is part 3. Again, if you can refresh, it will go to the part 2. So like this, it will able to distribute. Okay. Now let me tell you one real-time use cases where the load balancer will helpful for us. You have front-end UI application and back-end APIs and payment service. So same project we will do it in the coming videos. For front-end must be accessible publicly. So in production, load balancer service is created for front-end. Cloud load balancer gets the public DNS name or public IP. And very important thing is we need to be apply for the SSL or TLS certificates. So that feature is available here. So, and one more feature is available here. So auto scaling, then finally traffic is distributed across the parts. Despite of traffic spikes during the sales with the payment service, load balancers keeps application stable because auto scaling is available. So this is where load balancer become mandatory. Node port is not used here. Even cluster IP is internal, that is not sufficient here. So ingress maybe sit on the top of this load balancer, but base foundation is we can use load balancer here only. We will see that ingress controller in the coming classes as well. So when to use this load balancer means the use case is when the application must be public with the security and which is running on the cloud. And even very important thing is make sure our application is high availability. That time also we can use this load balancer. And more important thing is for production workloads we can use this load balancer. And there are some cases where we can avoid the load balancer when we want to access local clusters for internal accesses or internal service perspective. If you have too many microservices, then we can go to the ingress controller instead of load balancer. So these are the few things. So we can discuss clearly with this load balancer for other features, how we can integrate SSL certificate on TLS certificates, what are the types of load balancers are available, and what is the differentiate for all those load balancers. All those things we will see while discussing that AWS, and even when we will discuss in the projects as well. Okay. So eventually you should now clearly understood how Kubernetes exposes application to the outside the cluster with the particular ports. So because here we can use node port also, but it has the port range. Okay. Now let's see deletion part or destroy part. kubectl delete -f lb -svc.yaml. Before deleting, let's see here the load balancer is available, and when we apply this, the load balancer is trying to delete. See here, it got deleted. Okay, so remember here, when you apply that load balancer service type in Kubernetes, by default classic load balancer will be created. If you want, we can put what load balancer we need in the manifest file, that we will see it later. And again, kubectl delete -f deploy.yaml. Even the parts also getting deleted. kubectl get parts. See here, nothing is there. kubectl get svc. Okay, only default, which is on cluster IP, is there. In the next video, I will show you how to create or how to deploy EKS cluster by using Terraform code. I will share both Terraform code and the steps to create the EKS cluster. So if this video is helpful for you, could you please like, share and subscribe. Thanks for watching.